here as I move on because of the nature of the animations of the slides. Now, when we look at the convergence diagnostics, we see that for the autocorrelation plot, the chain moved away from its initial value rapidly, with the sample path wiggling vigorously in the area supported by the, the distribution of the parameter, an indication that the chain was well mixed. And it's important for the chain to be well mixed for for convergence. And for the auto correlation plot, we also see that the, the dependencies of the realizations were in 10 iterates apart. So we see that on the lag, the axis, we see 0, 10, 20, 30, 40, and so on. And as the 10 iterates increased, there was an observed exponential decay, suggesting independence in the iterates. In other words, the observations that the estimates or the realizations we got from the MCMC were independent, and that is also a condition that we need that ought to be met for us to know that the MCMC had actually converged. Now, I tried to superimpose the estimates of INLA on the MCMC, and for the simple linear model, this is what we have. We see that the red outline uh, constitutes the estimates of the INLA, and the histograms constitutes the estimates or the realizations from MCMC, and we see that they overlap pretty well. Now, for the generalized linear model, we also had to do same and overlapped very well. Now, as I've already discussed the convergence because of the trace plots, let me just move on to the accuracy. So we see that the estimates of tau, beta naught, and beta 1 were very equivalent when um, um, both estimates for when the estimates from both techniques were compared. And then when we look at the time, we actually timed the processes, and MCMC for the simple linear model took 5.14 seconds to give us the realizations, and for the generalized linear model, it took 21.87 seconds to give us its realizations. But INLA in both instances took less than 3 seconds. And then when we look at the computational burden, we see that MCMC is more computationally intensive than INLA, because with MCMC you need to identify your prior, you need to identify your likelihood, determine your posterior distribution, and then deduce your full conditionals from which you will determine or estimate the parameters. And INLA was just a matter of identifying your response variable, your covariates, the data, and then applying the INLA function. So the significance and the conclusion of this work is that INLA outperformed MCMC in terms of the time of execution, because MCMC in both cases took less than 3 seconds, but INLA in both cases took less than 3 seconds, but MCMC for the simple linear model took more than 5 seconds, and then for the generalized linear model took more than 21 seconds. Now, when you talk about the accuracy, we saw from the table of values that they were very equivalent. They were not, there was no much difference between the estimates from both techniques. And then we also have seen that the MCMC was computationally burdensome compared to INLA. So our conclusion basically is that on the basis of accuracy, execution time, and computational intensity, INLA is a good vision inference technique that can be used instead of MCMC when estimating parameters of simple and generalized linear models. Thank you.
Thank you, John, for that good presentation. I think you've taken a few more minutes over your allocated time.
Sorry.
We now invite comments and questions from the audience. Can raise your hand. Yes, Dr. Jerry Ochola.
Thank you, Prof. John.
Talk.
Well, you've tried to make one good presentation here. But I was very interested when you started saying that you actually was trying to actually show that Markov chain or INLA is better than Markov chain. Monte Carlo Markov chain, of course, as you know,
not necessarily better. Let me correct, but it can be a good substitution, a good substitute approach to MCMC.
Sorry, John, I've not even said my question or comment.
Yeah, I'm just trying to let you know that the agenda was not to prove that INLA was better. It was just to show that it's a good substitution. That's all. But you can go ahead with the question.
John, allow Dr. Jerry to finish the question, then you'll respond.
Yeah.
Thank you, Prof, for protecting me. John, you should just have left to finish. So I was actually trying to say that, well, you've already, from your studies, Markov chain is a well-established approach, mathematical and statistical approach. So is INLA, by the way. So when the way you built your story and the way you actually concluded is that the only thing or the only area that INLA was becoming or having an edge over Markov chains was actually computational time. Okay. My question number one.
Yes.
What was the platform? Which platform did you use to run your computations or executions that you're talking about? And the two.
Wait. Let him ask the second question.
For you to come up with the conclusion that MCMC took more time to execute than INLA, did you consider any other platform so that you actually compare two platforms to actually come up with this concept? Did you consider more than one platform to actually run your executions? John.
Can I?
Jerry, you are through?
So
yes, please.
Yeah, all at the introduction, I said that this study was carried out in R.
Okay.
So basically, everything was done in R. I have not tried any other platform.
Okay.
Yes.
Good. Thank you.
Prof, before you go,
Prof, I think he's not done
yes.
Yet.
Okay.
Before you go, John, R is very old, and R, you should they're actually much faster platforms that will actually give you a faster rate of execution than R. So when you talk about R, you will not have, don't talk about the time of execution. Look for another parameter, because R, when you compare R and MATLAB or R and Python, you'll discover that maybe Markov chain could have done better in terms of time of execution. In my opinion, you should actually look for another platform if you want to have a better conclusion for your study.
Okay.
Thank you. But as far as I'm concerned, I know that R is a software for analyzing statistics, basically. So is MATLAB, so is all the other Python and all that. If you talk about it's old, I don't get that, because they keep giving us updated versions anyway. Besides that, it looks like your focus is more on the time, other than the values which were estimated, and the fact that they estimated the values, and then you did not even look at the computational burden of MCMC, because MCMC, you had to go through a vigorous computation before you can even run it in R.
Sorry, John, can you go to your last slide? Can you just scroll to your last slide, the conclusion?
I think my laptop just froze, but
okay.
yeah, it just froze, so I'm not able to move. I would have moved a bit, but I think Godfrey has them. He can help us if he's able to.
No. Just to cut you short, I'm talking about the time, because that is the only thing you quoted that is the difference between the two. You actually said the accuracy was the same, the results were the same, but only the time so that is why I'm quoting actually the time. But when you gave us any other parameter, I would have actually seen that even the other parameters, there was a difference between the two approaches. But the reason I'm saying R is actually old, I didn't mean old by age, so is MATLAB. But if you talk about computation of Markov chains, there are systems that run Markov chains under 5 seconds. That's what I'm telling you. So if R will do it in 5 seconds, Python will do it in microseconds, for example. That's actually what I'm trying to suggest to you. So can you try any other approach and see if INLA can still do it in less time than Markov chain? So I'm just trying to give you suggestions.
So that's
thank you, gentlemen.
But Prof, let me chip this in, that as much as we're looking at the time, it also depends on the gravity of the data, because if you use data from spatial statistics, for instance, it's heavy. So definitely it will be time consuming, whether you use R or Python or whatever. So I appreciate your comments on the time, but all I'm trying to put across here is that besides the time, it is even computationally burdensome to use MCMC than INLA. So we can at the end of the day, we can have estimates. That's fine, but how much work goes into arriving at the estimates we have? That's another thing we need to consider. The time, yes, but the computation are very intense in MCMC than in INLA. And whether you use Python or whatever platform, the intensity of the computation is not going to change. So that's the point I want to also add to the time that Doc is trying to bring across.
Thank you so much, gentlemen. I believe that the presentation now has generated the interest it deserves, and Dr. Jerry and Mr. John Dakwa will link up now for more clarifications. Yes. So as now science will gain. Thank you very much, John, for that nice presentation.
Thank you, Prof.
Thank you. Now we are supposed to have our next presenter. I'm not sure whether he's around. that is Juma Simiyu. Is he around? I have not seen him on the list of people present. Okay. That means that this presentation brings us to the end of our presentations this morning. And according to the program, I'm seeing we are supposed to have a poster session and then proceed for lunch break. And the time already passed. We were supposed to have gone at 13:10. And then we shall be coming back at 14:00 for keynote speakers. So at this juncture, therefore, I would request the Secretariat to take us into the poster session. But before that, I want to thank the presenters so much for giving us the new knowledge that they have presented to us, and urge you to continue being with us and attend the other sessions. I thank the ICT persons for enabling the presentations to take place up to where we have reached. And therefore, with that, thank you. I wish you good lunch for the remaining few minutes. Thank you.
Thank you, Prof.
The theme of this session is progressive textile. The presentations will include sustainable textile technologies, textile engineering, technical textiles and composites, textiles of the future. Welcome to Symposium 3. The theme of this session is progressive textile. The presentations will include sustainable textile technologies, textile engineering, technical textiles and composites, textiles of the future. Welcome to Symposium 3. The theme of this session is progressive textile. The presentations will include sustainable textile technologies, textile engineering, technical textiles and composites, textiles of the future.